Today we will discuss about triggering of flip-flop. What is a triggering of a trigger? The state of a flip-flop is switched by a momentary change in the input signal. This momentary change is called a trigger. So when an input signal is applied to the flip-flop, it changes the state from one state to another, and that momentary change is known as trigger, and the transition it causes is said to trigger the flip-flop. So there is a transition from one state to another that is known as trigger the flip-flop. There are two types of circuits are there, asynchronous and synchronous. The asynchronous circuit require a input trigger, but the synchronous flip-flop are triggered by pulses. When a pulse is applied to the clocked flip-flop, it changes from or transition takes place from one state to another state. So we know that a pulse, that is the initial value of that pulse is 0 and it goes momentarily to 1. After a short time it returns to its value 0. For example, here this is a pulse. This is a pulse. It starts from 0 and is moved to 1 and it stay in 1, and after a short time it goes to 0 from 1 to 0. This is a pulse. Here there are two types of pulses are there. One is positive pulse, another one is negative pulse. In the positive pulse there is a transition from 0 to 1, that is known as positive edge, and there is a transition from 1 to 0, that is known as negative edge. In the case of a negative pulse, there is a transition from 1 to 0, that is known as, here it is 1 to 0 is known as negative edge, and here there is a transition from 0 to 1, that is known as positive edge. Then response to a positive level, then level triggering and edge triggering are there. Level triggering means is here there is a 1 is here, in that time it will change the or transition take place from one state to another stage. So flip-flop transition or state change from one state to another state during this high level or either high level or the low level, that is known as level triggering. So this high level is known as positive level triggering, and this low level, if the state change from one state to another or flip-flop state change from one state to another during this negative level or negative pulse, then it is known as negative level triggering. And this is an example of positive edge triggering. Positive edge triggering means during this positive edge there is a transition from one state to another stage, and negative edge triggering, during this negative edge there is a transition from one state to another. And the feedback path of a sequential circuit can produce instability if the output of flip-flop are changing while the output of the combinational circuit. We know that already, raising condition. If the level, the clock signal is, in the case of a level triggering, if the clock pulse is long for a long time, then or the clock is high for a long time, then there will be a occurring race around condition. To avoid race around condition, we are using different techniques. One of the technique is edge triggering. So in this edge triggering, in this type of flip-flop, the output transition occurs at a specific level of the clock pulse. So here output transition is occur at a specific levels of the clock pulse. There are two types of edge triggering, positive edge triggered and negative edge triggered. In the positive edge triggered flip-flop, that straight transition take place only at the positive going edge of the clock pulse. That is, if this is a clock pulse, then only the transition take place on the positive edge of the clock pulse. That is 0 to 1 or low to, here it is 0 to 1, 0 represents low and 1 represents high. That is, during that time only the transition take place from one, or state change take place from one state to another state. Then next is negative edge triggering. Negative edge triggered flip-flop state transition. State transition means changing from one state to another state. Take place only at the negative going edge of the clock pulse. Negative going edge pulse means this is positive edge triggering, and here negative edge triggering when during the negative clock cycle, negative going edge, that is 1 to 0, during that time there is a state transition occurs, and that type of flip-flops are called negative edge triggered flip-flop. Positive edge triggering is indicated by a triangle at the clock terminal of the flip-flop, and negative clock cycle indicates, or edge triggering is indicated by the triangle with bubble at the clock terminal of the flip-flop. For example, here this is the diagram. Positive edge triangle, edge represents like triangle, only there is a triangle there, it indicates positive edge, and bubble, the triangle with bubble, it indicates നെഗറ്റീവ് എഡ്ജ് ട്രിഗറിങ്. അപ്പോൾ നമുക്കൊരു ഫ്ലിപ്പ് ഫ്ലോപ്പ് പോസിറ്റീവ് എഡ്ജ് ട്രിഗറിങ് ആണോ അല്ലെങ്കിൽ നെഗറ്റീവ് എഡ്ജ് ട്രിഗറിങ് ആണോ എന്ന് അതിൻ്റെ ഡയഗ്രം നോക്കിക്കഴിഞ്ഞാൽ മനസ്സിലാവും. ജസ്റ്റ് ഒരു ട്രയാങ്കിൾ മാത്രമേ ഉള്ളെങ്കിൽ അത് പോസിറ്റീവ് എഡ്ജാണ്. ഒരു ബബിൾ വിത്ത് ട്രയാങ്കിൾ ആണുള്ളതെങ്കിൽ ദാറ്റ് ഈസ് നെഗറ്റീവ് എഡ്ജിലാണ് ട്രാൻസിഷൻ ഒക്കർ ചെയ്യുന്നത്. Then next one is edge D-type positive edge triggered flip-flop. The logic diagram D-type positive edge triggered flip-flop is shown in this figure. So D-type positive edge triggered flip-flop is there. It consists of three basic flip-flops. This is first flip-flop, and this one is second flip-flop, and this one is the third flip-flop. So here it represents 1, 2, 3, 4. Here it is 4, 5, 6. There are 6 flip-flops. NAND gates are there. First two NAND gates, gate 1 and 2 forms a basic flip-flop. Another 3 and 4 forms another flip-flop, and 5 and 6 is another third flip-flop. And here the gate output 5 and 6 provide the output of this circuit, that is Q and Q dash, and the input S and R, here input is S and R of the third flip-flop must maintain at logic level 1 for the output to remains in the steady state values. If S and R inputs are 1, 1, then this Q and Q bar state will be in a steady state value. When S is equal to 0 and R is equal to 1, what will be the output? S is equal to 1, R is equal to 1, then it is a S is equal to 1, S is equal to 0 and R is equal to 1, then output goes to a set state. It is a NAND gate, so here output goes to a set state, that is Q is equal to 1 and Q bar is equal to 0. If next case, if S is equal to 1 and R is equal to 0, then the output goes to a clear state, that is here R is equal to Q is equal to 0 and Q bar is equal to 1. So this is the stage, SR input stage. S is equal to 1, R is equal to 0, it is stage changes from one state to another. The input SR determines from the states of the other basic flip-flops. So this input S and R, these two are determined from the state of the other two basic ഫ്ലിപ്പ് ഫ്ലോപ്പ്. ഇപ്പം നമ്മളിവിടെ പറഞ്ഞിരിക്കുന്നത് എന്നാന്ന് വെച്ചാൽ എസ് ആർ വെച്ചിട്ടാണ് നമ്മുടെ ഔട്ട്പുട്ട് ഡിറ്റർമിൻ ചെയ്യുന്നത്. എസിൻ്റെ ആറിൻ്റെയും വാല്യൂ ബേസ് ചെയ്തിട്ടാണ് ഔട്ട്പുട്ട് ചേഞ്ച് ചെയ്യുന്നത്. അപ്പോൾ എസ് 1ഉം ആറ് 0 ആണെങ്കിൽ റീസെറ്റ് സ്റ്റേറ്റ് ആണ്, റീസെറ്റ് സ്റ്റേറ്റ് വരും. ദെൻ 0 Q 0 ആവും. ഇനി എസ് 0ഉം ആറ് 1ഉം ആണെങ്കിൽ സെറ്റ് സ്റ്റേറ്റ് ആണ്, അപ്പോൾ Q1ഉം Q ബാർ 0 ആകും. അപ്പോൾ ഈ എസിൻ്റെയും ആറിൻ്റെയും ഇൻപുട്ട് വാല്യൂ ആരാണ് ഡിറ്റർമിൻ ചെയ്യുന്നത്? നമ്മുടെ ഫസ്റ്റ് രണ്ട് ബേസിക് ഫ്ലിപ്പ് ഫ്ലോപ്സ് ആണ് ഡിറ്റർമിൻ ചെയ്യുന്നത്. ദാറ്റ് ബേസിക് ഫ്ലിപ്പ് ഫ്ലോപ്പ്, ടു ബേസിക് ഫ്ലിപ്പ് ഫ്ലോപ്പ് ആർ റെസ്പോൺസ് ടു ദി എക്സ്റ്റേണൽ ഇൻപുട്ട് ഡി ആൻഡ് ക്ലോക്ക് പൾസ്. സോ ഈ രണ്ട് ഫ്ലിപ്പ് ഫ്ലോപ്പിനെ ഡിപ്പെൻഡ് ചെയ്യുന്ന ആരാണ്? ഏതിനെ ഡിപ്പെൻഡ് ചെയ്തിട്ടാണ് വർക്ക് ചെയ്യുന്നത്? ഡി ആൻഡ് ക്ലോക്ക് ഇൻപുട്ട്. സോ ഡി ആൻഡ് ക്ലോക്ക് ഇൻപുട്ടിനെ ബേസ് ചെയ്തിട്ടാണ് ഇവിടെ എസിൻ്റെ ആറിൻ്റെ ഔട്ട്പുട്ട് പ്രൊഡ്യൂസ് ചെയ്യുന്നത്. ദെൻ അതിനെ ബേസ് ചെയ്തിട്ടാണ് ക്യൂ ആൻഡ് ക്യൂ ഡാഷ് വർക്ക് ചെയ്യുന്നത്. From this next, the operation of the circuit is explained here. From here we are redrawn the gates. Here 1 2 3 4. These 4 gate 1 to 4 are redrawn to show all the possible transitions. The output S and R from the gate 2 and gate 3 goes to the gate 5 and 6. This provides the actual output of the flip-flop, that is Q and Q bar. Here we are going to discuss what is the value obtained S and R when Cp is equal to 0. If Cp is equal to 0, then either the value of D may be either 0 or 1. Then what will be the SR value? Here we know that this is a NAND gate. When Cp applied here 0 0, then any one of the input of the NAND gate is 0, then output will be 1. We know that S and R will be 1. When an input D is equal to applied to the gate of 4, then that D value is 0. Then anyone in ഏതെങ്കിലും ഒരു ഇൻപുട്ട് NAND ഗേറ്റിൻ്റെ 0 ആണെങ്കിൽ ഔട്ട്പുട്ട് എന്തായിരിക്കും? 1 ആയിരിക്കും. Then this 1 will be goes to here. This is 1 and here S output will be 1. Output of gate 2 will be 1. So this will be 1. Then both input are 1. Then output will be 0. So here Cp is equal to 0 and D is equal to 0. It changes the gate 4 to output of the gate 4 to 1. And that 1 makes the gate 1 to output of the gate 1 to 0. And here when Cp is equal to 0, causes the gate 2 and 3 goes to 1, thus making S and R equal to 1. That condition is known as steady state output. Then it is known as, if S and R are 1, then it is known as steady state output. And here when D is equal to 1, what will be happen? Here we know that D is equal to 1, then already last output is 1. Here output of gate 3 is equal to 1. Then this 1 is come here. Then both inputs are 1, output will be 0. So when D is equal to 1, the output of gate 4 will be goes to 0, and which goes the output of the gate 1 goes to 1. But because here it is one, any one of the input is 0, then output will be 1. And if Cp is equal to 0, here output becomes 1 1. Any one of the input is 0, then output becomes 1 1. And these are the two possible conditions when Cp terminal being 0. That means it disables any changes at the output of the flip-flop. So നമ്മളിവിടെ ഓൾറെഡി ഉണ്ടായിരുന്ന വാല്യൂവിൽ ഏതെങ്കിലും ഒന്ന് ചേഞ്ച് വരുന്നുണ്ടോ? എല്ലാം പ്രീവിയസ് വാല്യൂ തന്നെയാണ്. So it disable any changes at the output of the flip-flop, no matter what the value of D happens to be. സോ നമ്മൾ വാല്യൂ ഡീൻ്റെ വാല്യൂ 0യോ 1ഓ ആയിക്കോട്ടെ, എന്തായിരുന്നു പ്രീവിയസ് സ്റ്റേറ്റ്, ആ സ്റ്റേറ്റ് തന്നെയായിരിക്കും ഇതിൻ്റെ എല്ലാ ഗേറ്റിൻ്റെ ഔട്ട്പുട്ട് കണ്ടിന്യൂ ചെയ്യുക. അപ്പം നോ ചേഞ്ചസ് ആണ് എസിൻ്റെ. നെക്സ്റ്റ് we will explain what is the value of S and R when Cp is equal to 1 and D is equal to 0. Before that, there is a definite time which is called as setup time. Setup time, in which the D input must be maintained at a constant value prior to the application of the pulse. So in the setup time, before applying a pulse, the value of D input is maintained at a constant value. The setup time is equal to the propagation delay through gates 4 and 1. Here there are two gates, 4 and 1. Since a change in D causes a change in the output of these two gates. We know that when D is changed from 0 to 1, this gate value of 4 and 1 is changed from 4 is changed to 1 to 0, and gate 1 is changed from 1 to 0. So here there is a change is occurred. So 0 to 1. So there will be a changes occur when D is changed from 0 to 1. And assume that D does not change during the setup time. That input Cp change to the input of Cp becomes 1. Then what happened in this? If D is equal to 0, here D is equal to 0, and when Cp becomes 1, then S remains 1 but R changes to 0. Then flip-flop Q goes to 0. Here how will be the effect? Here D is equal to 0, any one of the input of the gate 4 is 0, then output becomes 1, and this 1 is going to here, this is 1. And when Cp is equal to 1, then we are checking the previous value. Here it is 0 0 1. Then any one of the input is 0, output becomes 1, and this 1 becomes here, and Cp gate becomes 1 here, and this 1, all the inputs of the gate 3 becomes 1, then output will 0. Then here it is 1, output of the S is equal to 1, here also 1, then both inputs are 1, then output becomes 0. So when D input is equal to 0, then output of the gate 4 becomes 1, this output goes to here, and gate 1 changes to 0. Also, the S and R value change. The S is equal to 1 and R becomes 0. Now, while the CP is equal to 1, then there is a change in the D input. If D input is changed to 1, what will be happen? If R is equal to 0 here, then one of the input is here is 0. If it changes, D is changes from 0 to 1. So what will be the output? Output will be 1. Gate 4 output will be remains at 1 even if D goes to 1. Since the one of the gate input comes from R is maintained at 0. When CP returns to 0, if it changes from 1 to 0, can the output of the gate 4 change. So if we change the value of CP to 0, then this will be 0, then output of the R will be changed to 1, then that will be make the change in this output of the gate 4. If both inputs are 1, then output becomes 0. So അതാണ് പറയുന്നത്. ഇപ്പം സി പി ചേഞ്ച് ആവുന്നവരെ എന്താകും, സി പി ഒരിക്കൽ 1 ആയി അവർ ചേഞ്ച് ഒക്കർ ചെയ്തു, ദെൻ പിന്നെ ഡിയുടെ എന്ത് വാല്യൂ ചേഞ്ച് വന്നാലും ഏതിൽ എഫക്റ്റ് ചെയ്യില്ല, ഗേറ്റ് 4ൻ്റെ ഔട്ട്പുട്ടിൽ എഫക്റ്റ് ചെയ്യില്ല. കാരണം ഈ ആറിൻ്റെ 0 ആണ്, ആ 0 എപ്പോഴും ഇവിടെ വരും. അപ്പോൾ എപ്പോഴും എന്തായിരിക്കും, ആ ഡിയുടെ ഔട്ട്പുട്ട് വാല്യൂ എന്ന് പറയുന്നത് ചേഞ്ച് ചെയ്ത ഗേറ്റ് 4ൻ്റെ ഔട്ട്പുട്ട് വാല്യൂ ചേഞ്ച് ചെയ്യില്ല. പക്ഷെ സി പി 0യിലേക്ക് ചേഞ്ച് ചെയ്യുമ്പോൾ ആറിൻ്റെ വാല്യൂ എന്താവും, സ്റ്റഡി സ്റ്റേറ്റ് വാല്യൂ ആവും. ആ സ്റ്റഡി സ്റ്റേറ്റ് വാല്യൂ കൊണ്ട് എന്താവും, ഡി ഔട്ട്പുട്ട് ഓഫ് ദി ഗേറ്റ് 4 എന്ത് ചെയ്യും, ചേഞ്ച് ചെയ്യും. Then both we know that both S and R becomes 1 and it disabling any changes in the output of the flip-flop. And there is a definite time known as called as hold time. Hold time, that the D input must not change after the application of the positive going transition of the pulse. The hold time is equal to the propagation delay of the gate 3, since it must be ensured that R becomes 0. R becomes 0 in order to maintain the output of the gate 4 at 1, regardless of the value of D. And suppose D is equal, when CP is equal to 1, if D is equal to 1, D is equal to 1, then what will be the output? If D is equal to 1, then CP is equal to 1. Here both CP is equal to 1. Then here we know that in the previous output of this 1 0 1 0, then this 0 goes to here, then this gate becomes 1, then this 1 is here, both the inputs are 1, output will be 0. This 0 goes to here, any one of the input is 0, then output becomes 1. This also 0 here, so it becomes 1. So when S input is 0, then gate output 1 will be 1. So then changes S to 0, but R is remain to 1 here in, and which causes the output of the flip-flop goes to 1. Then this is connected to the another flip-flop, and that output of that flip-flop is Q and Q bar. If S is equal to 0 and R is equal to 1, then this Q go to 1. Then we change this D to 0. If there is any change in this D is equal to 0, then Cp is equal to 1. If it is 0, there's any input. If here it is 0, then what will be the output? Here it is becomes 1. Here gate 4 becomes 1. Any of one of the input of NAND gate is 0, output becomes 1. This 1 will be goes to the input of the gate 1. Suppose here gate 1 is changed to 0. Then here it is any one of the input of this gate is 0, then output becomes 1. This 1 will be given to the input of this gate. We know that already S value is 0 here. So this 0 make the gate 1 output to 1. It continues its state. There is no change in this output of the gate 1. So here it is 1 and here it is 1. If both inputs are 1, 1, the output becomes 0. And this 0 is goes to here, then any one of this input is 0, then output becomes 1. So if there is a change in this D, it will not affect this S and R value. That is, a change in D while Cp is equal to 1 does not alter the S and R, because the gate 1 is maintained at 1 by the signal 0 from this S. When Cp goes to change to 0, then this both S and R to prevent the output from outgoing any changes. If it is 0, then here what will be happened? If both are 0, here Cp is changed to Cp is changed to 0, then these both input value becomes 1 1. S and R 1 1. That is steady state. Then it prevents the output from going any changes. So if S and R 1 1, there is Q and Q bar are steady state. Then in summary, when the input clock pulse make a positive going transition, if the input pulse, this is the input pulse, it's a going positive going transition, the value of the D is transferred to the output Q. Changes in the D when Cp is at steady state 1 value does not affect the Q. Moreover, a negative pulse transition does not affect the output, nor does it when Cp is equal to 0. So Cp is equal to 0, then output has no change. And when Cp is equal to 1, then according to the D input, if D is equal to 0, then S becomes 0. Then that will be transferred to Q. If D is equal to 1, then S becomes 0. Then that will be transferred to Q. So when during this negative edge pulse, there is no transition or it does not affect the output. So it is maintained in the previous stage. Hence, the edge triggered flip-flop eliminates any feedback problem in the sequential circuit, just as a master-slave flip-flop does. So in the master-slave flip-flop, we are eliminate the feedback problem. So here also edge triggering, the going negative pulse transition, it does not affect the output. So here it eliminates, edge triggered flip-flop eliminates any feedback problem in the sequential circuit. And here we consider the setup time and hold time must be taken into consideration when this type of flip-flop.